Okay, so the component to understand what each of them are doing. So pig is it's also kind of an ETL tool, which is a kind of an alternate to write the MapReduce code, because not everybody know the Java, and the people who don't know Java, they find it difficult to write the MapReduce program. So to help uh, those use cases where you don't have to write the Java, pig is made so that you just write some pig queries, and then underlying it will convert it into the MapReduce jobs. Okay, it's also an open source. It is also kind of a layer on top of the MapReduce, and it's one of the very something where if you have to just quickly get on started, do some small processing in few steps, just maybe 4 or 5 lines, you want to do everything. Pig is very handy to do all of that. It's an interpreter based. There's no problem of compiling and all of that. It's a script based language. Okay. And then we have the Impala. It's proprietary to the Cloudera. Uh, it was proprietary. I think now also it's proprietary to the cloud. Impala is proprietary to the Cloudera. But
Here inside.
yeah,
In Spark, it is said that it brings the data into memory and then it processes it. So if we process 100 lines in each node and then the final set of data, it is in an earlier query it was clear that in HDFS it itself it will process and it will give us the final query. But what if it will bring the data into memory, and how the accumulation of all the 100 data into a single one it will happen?
very good. So yes, you are right that it brings the data towards the memory, and then accumulation and everything will also. So let's say if you have to accumulate all the results, for example, right? So
Yeah.
you can, yeah, so it will go from in memory from node to node communication. So there will be two components on two different nodes talking to each other, and then if you have to accumulate, so accumulation, usually there are two types of accumulation. First thing is you have to accumulate the entire data and store it as one on one particular node. That there are some operations which needs like all the data to be moved to one node. Right. So in that case, what will happen? All of the data will be consolidated from all the nodes. It will go flow to one particular driver, and then you store it in it. So this is one type of thing. Second thing is, if you want to store the result, so let's say uh, you have performed some transformation on all of the data, and then you want to store the data. So in those cases, the accumulation is not required. You can directly store the data on the HDFS. HDFS is a distributed file system. So once you store it into there, all of the nodes will be storing to a distributed file system, and then in those cases, you don't have to accumulate all the results. So say for example, so what's your STFS? STFS is distributed, which is like all the 100 nodes. It's like a distributed file system is like assume a Google Drive, for example. I'm just giving some. So Google Drive is, let's say in Google Drive you have 3, 4 folders, okay, and Google Drive is shared across 100 people. So all 100 people can store their data on those Google Drive, on those 4 folders, for example, right? So what will happen? 100 people are storing their output on. Okay, yes, STFS is kind of a distributed storage, right? Let's say you created a folder like the slash program output. This is my folder where I want to put the program's output. Now to create the output, I have 100 nodes which is processing the data, and all 100 of them are storing into this. So in this case, I don't have to accumulate all of that. All of them will be connected to this and storing over here. I will get a single snapshot output from all the 100 nodes getting written at one location. Okay, even though it is happening in the memory, but since the output of the memory is getting stored on a HDFS, I don't have to worry about accumulating and putting and then putting. So all of them has access to FS. It's like 100 people having access to a Google Drive. So as 100 people can put their files on a Google Drive all together, you don't have to share with each other, accumulate and push it once, right? All of them can upload their individual files. So similar to that, all 100 nodes, once their work is done, they can upload their file to a particular HDFS directory, and there's no need of accumulation at all. Okay.
Okay.
Okay. Very good. So similar to that, we have a Impala, which is kind of a high performance SQL engine. So Impala came into picture because Hive was slow. So to improve the performance of the SQL on top of Hive, so on top of HDFS, the Cloudera they made Impala. And what they do is they also try to improve the performance of the SQL engine. So with a very low latency, it was supporting it was giving some faster query results on top of Hive. So that's what I would say. Very much similar to the Hive, but it is better in terms of query performance.
Hi, Dheeraj, this is Dikshit. I have a quick question.
Yes.
So just like how you explained, like Impala looks like it's better than Hive in all the aspects. Is there a case or is there a use case where Hive will be still preferred over Impala?
See, any sort of this type of tool who is giving you a better performance, they are giving on terms of cost for the RAM consumption. So even Impala stores a lot of the data in memory, same as the Spark, right? So any such type of thing who is giving you a faster query, they have a limitation in terms of how much of the data you are dealing with. Okay, so some people say like, okay, the range is 1 terabyte or something like that, but usually I would say if you are running some query over more than let's say 500 terabyte and all, so you might have multiple issues with the Impala, which might not be that much with the Hive, I would say. But even Hive has its own issues, but one of the use cases I say like that is one of the things.
All right. Thank you.
Okay, and then comes the Hive, and let me tell you, like Hive is one of the most popular tool used across the entire industry. Whoever using the Hadoop. And the reason for it being so popular is because the people, most of the IT people, they know SQL, right? SQL people have been using since maybe 30 years now. So everybody knows SQL now. And since everybody knows SQL, they find Hive as something which is very similar, and all the concepts are very similar to the relational world concept. So all the queries are similar. Everything is very similar. So they find it very quick to learn, run the queries, and so that's one of the major reasons why it's so popular. So it's very similar to the Impala. Impala is Cloudera's product, and Hive is the open source Apache's. It's open source under the Apache. Okay, so Hive is something I if I remember, I am sure. So it is made by the Facebook. So Facebook built this Hive because most of their developers were familiar with the SQL, and to support them to run their queries on top of big data, they built this Hive. So underlying it is MapReduce, but on top of it is Hive queries. Okay, and then once they made this software, they made it open source under the Apache license and all. So that's again performing all the ETL, and it's very similar to Impala. Then we have the Cloudera search. It's again something which is very proprietary to the Cloudera. So it's something where Mhm. Yeah.
Yeah, so in comparison to again Hive and Impala, I mean, as we see, like Impala has better performance, but as you also mentioned, like most of the time we see like Hive is primarily used
Yes.
So is it because of very similarity to SQL, or what is the reason?
Yes, which is very similar to the SQL. Second thing is Impala is only present in Cloudera. So if you are working with Hortonworks, you are working with Mapr, you are working with any other distributions, you will not have Impala in it. Okay, so that's why Hive is more widely used, because not everybody uses Cloudera.
Okay, makes sense. Thank you.
It is written as executes queries using MapReduce. So can you explain us that only through MapReduce it will execute the queries, or we can use Spark also?
Yeah, it can run. So yeah, so earlier it was only MapReduce. Nowadays they have improved the Hive as well. So now what they have done is they have given an option to choose an execution engine, right? So like execution engine is like they have given options to use the TEJ. This is one of the execution engine, which is nowadays it comes automatically with the Hortonworks, or you can choose the Spark and all of that, right? So the earlier it was only MapReduce. Now they have kind of made the users to choose what execution engine we want for Hive.
Okay.
Okay, very good. So let's quickly go on to the next component, which is a Cloudera search. So it's so search is simple. Like Cloudera gives you a way where you can search out for the data. If you have your data present in some sort of HBase or HDFS anywhere, so using this you can search the data where it is present, and it will give you the result. Okay. The next one is oozy. So as we discussed, oozy is a workflow. So what you do is you have to create some sort of workflow. I want to do some 4 or 5 steps. Right, so we have to create a workflow like this. So start. So I want to start. I want to do some action, then second action, then third action, then fourth action. I want to do the action in sequence. So once my action 1 is done, I want to do action 2, action 3, action 4. And once all the action are done, then the end. So it's kind of a workflow which we can schedule, and it will follow the dependency. Like once this is done, then only it will done. If this is failed, it will fail there itself. And so that's what it is a role of an oozy. And then we have the hue. Hue is a graphical interface to the Hadoop. So if let's say I want some user interface where I want to access the data, I want to access the Hive, I want to access the pig, I want to access all of those from the user interface. So it's an open source user interface built for Hadoop. So we can run Hive queries using Hue. We can browse the HDFS file systems. We can see the HBase. We can run the big queries. So a lot of those things we can do using the Hue. It's just a graphical interface to Hadoop in simple terms. So all right. So before we go to the next, any questions so far?
Yes. The word Hadoop jobs. You see, what do you know? How the Hadoop jobs are organized? So
Sorry, I could not hear your question. Could you please repeat that a little louder, please?
you have mentioned as Hadoop job, right? In oozy.
Hmm.
So Hadoop job, how it will be generally when you say it's a job of processing in the script, it's compiled with X command.
Hmm.
That will be. So how it works here?
Hadoop jobs, right? So Hadoop job is any sort of job. So let's say my first action is I want to run some scoop process. Okay, that is my action number 1. In the second process, I want to run some shell script, for example. Okay. In the third
Okay.
process, I want to run a MapReduce job, and in the fourth action, I want to run a Spark program. So all of these things I can combine together in a workflow and can schedule it as a oozy job.
Okay.
Okay. All right. Okay. So yeah, so oozy is kind of a scheduler. It's kind of a workflow scheduler in the Hadoop. So you can use other schedulers also, but oozy is kind of part of the family to which you can use to schedule it.
I'm talking about MapReduce. Like MapReduce is used only for retrieving the data, or while it is used while we are storing data. Like if we are using a scoop, then does it also use MapReduce to store it, or no?
Yes, Scoop uses map job to pull the data and store it in the HDFS. So Scoop also uses mapper's job. Reduce is not required for a Scoop, but Scoop uses mapper jobs.
Okay. So while just wanted to know, like while storing also it is being used, or so mapper is used.
Yes, mapper is used. So mapper is like if you run a Scoop job, it will run multiple mappers. What this mapper will do? This mapper will connect to the database and then it will pull the data. It will store into the HDFL. That's what it will do, nothing else.
Okay.
In Hadoop world, a task are divided into two types broadly, mapper and the reducer. So when we talk about the map reduce, we'll discuss in very detail, but any task in Hadoop is divided into two things. Either you are doing some mapping or you are doing some reducing. There is nothing else apart from these two. Okay? So all this we'll be talking in detail, but so that's how usual processing happens. In a bigger picture, if you really see, you have a lot of data from different sources, right? It could be some social media feed or from your uh, customers' data or from some sales data or some transaction data, whatever, right? First, you have to get your data into the Hadoop. What are the tools? Two big tools, Scoop and the Flume, widely popular ones. You use these two to ingest your data. So ingestion, Scoop and Flume. For processing, you have multiple options. So you use Scoop, you use MapReduce, Hive, Big, anything you use. Okay. And then once all the processing is done, we have tools like Hive, Big, Impala, all this to analyze. So analyze will also run through some queries. Any sort of query you want to run, you want to do some joins, you want to find out anything, all that can be done using all these tools. Data access, if you want to access the data, there are different tools like Hive, Cloudera Search, and there are so many different tools like Tableau, QuickView, a lot of different tools are there to access the data, and then either you extract it as a CSV or you upload to some other uh, relational world, or you create some report, you perform some another analysis, whatever you want to do. All of the tools that can be used to take it further. Okay. But these are the four steps. Like ingestion is the first step, then you process, analyze, access the data as the output, and then access is nothing but you are exposing your data for different use cases. So that could be some data science initiative, some analytical use cases, some reporting, some visualization,